Okay, so let's unpack this. It's a pretty mind-bending idea we're looking at today.
It really is. Black holes,
Mm,
used as quantum computers by advanced alien civilizations.
sounds like pure sci-fi, doesn't it? But the physicist behind it, Gia Dvali, he builds a case that's, well, surprisingly grounded in some known physics.
Yeah, what's really interesting is how he starts by questioning something pretty fundamental. The relationship between energy and how closely we can look at things.
Right, the standard picture is more energy equals finer detail, like bigger microscopes, more powerful particle colliders.
Exactly. Higher energy lets you probe shorter distances. That's been the rule of thumb.
But Dvali kind of flips that.
Yeah.
He points out that if you keep pumping insane amounts of energy into a collision,
You don't necessarily get smaller pieces out.
no, you eventually just make a black hole.
Right. And adding even more energy beyond that point, it just makes the black hole bigger, not smaller.
So that whole more energy, shorter distance thing, it sort of breaks down.
It breaks down spectacularly. There's a limit, a fundamental limit related to gravity itself.
It's slank energy.
That's the one. It's this almost unimaginably high energy scale where our current physics, well, it kind of gives up. Quantum effects and gravity become equally important.
And we're talking way, way beyond anything like the Large Hadron Collider.
Oh, orders of magnitude beyond. 14 orders of magnitude, actually.
Yeah.
It's a theoretical boundary for now.
Okay, so you hit this energy wall, and that wall is basically black holes.
In a sense, yeah. And this leads to a really fascinating concept Dvali talks about, UVIR mixing.
UVIR, so ultraviolet infrared. What does that mean in this context?
It means black holes connect the physics of the very small, the high-energy, short-distance stuff, the UV, with the physics of the very large, the low-energy, long-distance gravity, the IR.
Huh. So what's happening at the tiniest scales inside is linked to its overall gravitational effect.
Exactly. It's like they bridge these two extremes. And Dvali's take on this is, well, pretty radical. He thinks we should understand black holes as basically a huge collection of gravitons,
Gravitons, the hypothetical particles that carry gravity.
the very same. He argues that these gravitons are what actually store the information. Information about what fell into the black hole, what it was made of.
So instead of some mysterious singularity, it's like a dense soup of gravity particles holding the data.
That's the picture he paints.
Yeah.
Since black holes are fundamentally gravitational objects, it makes a certain kind of quantum sense that gravitons would be the storage medium.
Okay. And this ties into the whole information loss problem, doesn't it? Where does the information go?
It does, and this is where other big ideas come in, like the holographic principle from Bekenstein and Hawking.
Right. The idea that all the info inside a volume can be, what, stored on its surface?
Yeah, encoded on the boundary. For a black hole, that boundary is the event horizon. So the information isn't necessarily deep inside. It might be accessible, in a way, right there on the surface.
Okay, so black holes as information archives, maybe with the info on the horizon. But then there's this other piece about them being dynamic, right?
Oh, absolutely.
Yeah.
Recent research really highlights that black holes are incredibly chaotic systems. They're not static storage vaults.
They do stuff with the information.
And fast. Anything that falls in gets mixed up and spread across that horizon incredibly quickly. Susskind and Sakino coined a great term for them.
What's that?
Fast scramblers.
Fast scramblers, I like that, because they just scramble everything up instantly.
Pretty much. They are thought to be the fastest possible scramblers of information in the universe.
Okay, so huge information capacity, potentially stored on the surface, and they scramble information super fast.
You see where Dvali is going with this, right?
Yeah, if you're a super advanced civilization looking for the ultimate computing device.
Wouldn't a black hole look pretty appealing? They hold the absolute record for information density per unit area. Nothing else comes close.
And they process it, or at least distribute it, incredibly quickly. So it's not just storage, it's processing potential.
That's the leap Dvali makes. It sounds audacious, but if you just follow the physics, the information density, the scrambling speed using them for computation starts to seem, well, almost logical for a civilization that could manipulate them.
So how would that even work? Aliens building black holes?
The idea is they might create tiny microscopic black holes first, maybe by colliding particles at energies we can only dream of.
And then what? Feed them?
Sort of, yeah.
Yeah.
Grow them carefully to an optimal size.
Hmm.
Dvali's calculations suggest something around maybe 1,000 tons.
1,000 tons, that sounds massive.
But physically, it would still be incredibly tiny,
Yeah.
smaller than an atomic nucleus.
Wow. Okay, that's hard to picture. A 1,000-ton black hole, smaller than a nucleus.
Right, and then maybe arrange these tiny, incredibly dense objects into arrays, like the circuits in a computer chip, but using black holes.
An array of black hole processors. That's
Yeah.
wild. So could we ever detect something like that if they exist?
Well, they wouldn't be completely silent. Even tiny black holes should emit Hawking radiation.
Ah, the slow evaporation.
Exactly. Dvali suggests these alien data centers would have a sort of characteristic exhaust signal from this radiation, a specific energy signature.
Like looking for heat signatures from Dyson spheres, but looking for Hawking radiation signatures instead.
Kind of, yeah. It's something we could potentially search for in sky surveys. A faint, specific glow that doesn't match other known astrophysical sources.
So the evidence might not be, radio signals or giant structures, but the faint whisper of evaporating black hole computers.
It's a possibility, however remote. And again, the amazing thing is how this seemingly sci-fi idea connects back to fundamental physics, UV-IR, mixing, information limits, Hawking radiation.
It really is a blend, isn't it? Taking known physics and pushing it to its most extreme speculative conclusions.
Definitely. It stretches the imagination, but it's rooted in concepts physicists grapple with every day.
Okay, so wrapping this up. If we follow this logic, even just as a thought experiment, black holes are maybe the universe's best information processors.
In terms of density and scrambling speed, seemingly yes.
So here's the final, really out there thought for you listening. If they are that good at storing and processing information, could they, in some sense, be considered intelligent?
Or even conscious.
Right. Could it be that we're surrounded by a form of distributed natural alien intelligence, these black holes that we just haven't recognized for what it is?
It certainly makes you look at the cosmos a little differently, doesn't it? A truly provocative idea to mull over.